This series of lectures is over agriculture and pest management. So we're going to look at the different methods of agriculture found around the world. Then we'll take a look at ways of decreasing the amount of chemical usage on our farms. There are two main types of agriculture: traditional agriculture and industrialized agriculture. So we're going to take them one at a time, and we're going to start with traditional agriculture. Traditional agriculture is practiced by about 44% of the world's farms. So a little bit less than half of the world's farms are traditional in style. Now, even though it's just a little bit less than half of the world utilizes this style of agriculture, it only makes about 20% of the world's food. So traditional agriculture is not as efficient at producing food as industrialized agriculture. One of the things that makes it traditional is the fact that it utilizes mostly muscle power as its energy source. So it's using human labor and draft animals, their actual muscle power, to provide the energy on the farm. Traditional agriculture itself comes in two types. The first type is called subsistence farming. In subsistence farming, the farm generates just enough food for the farmer and his family. So subsistence farms are not making food to sell in the local market, they're just making food for that particular group of individuals. So here we've got an example. This example is from South America, and it looks like these guys are taking their pigs for a walk on leashes, and that's really what they're doing. So each day this group of farmers would get up, they'd walk their pigs out into the forest, and the pigs would then forage in the forest, finding food all day. And at night the farmers would collect their pigs and walk them back into the village, where they're kept inside to keep them safe during the night. So these farmers are moving their pigs from the village into the forest each day and back each night. So this is taking lots and lots of work effort on their part. Obviously they can't move huge numbers of pigs because there's just physically not enough time in the day. So this is just generating food from a limited number of pigs and providing enough food for their family. So it's subsistence agriculture. The second type of traditional agriculture is called traditional intensive farming. And in intensive farming, what they're doing is they're generating enough crops not only for their family but also to sell. So here we have a traditional intensive farmer taking his melons to market for sale. So traditional intensive farms generate much more food than traditional subsistence farms. Intensive farms are intense enough, use enough energy inputs to generate enough food to sell at market. So for most of human history, when we've been living as an agricultural society, we've been conducting intensive farming, traditional intensive farming, generating enough crops to sell or barter or exchange for other goods. Traditional intensive farms have some large benefits. One of the primary ones being that they work extremely well if the economic conditions don't allow a farmer to pay for very expensive machinery. If a farmer can't afford to buy large expensive farm machines, human muscle power or animal power is often able to get that same job done. So on an intensive farm, it's generally large numbers of workers and animals that are providing the physical energy to actually do the tasks. This is often much cheaper than spending money on large planting machines, harvesting machines and tractors. So in countries with rapidly growing populations, there's often a ready workforce that will work on the intensive farm, providing the labor needed to harvest the crops. So in less developed nations, where large amounts of affluence are not present, but large population growth is taking place, we see traditional agriculture having a very defined niche. Traditional agriculture also works well in places where the land or the crop don't fit easily with mechanize agriculture with using machines. So if we have crops that are not easily planted or harvested by machine, utilizing people to do that work is often the most efficient way. If the farm is utilizing farming techniques that are difficult for machines to cope with, utilizing animals and humans is also an efficient way of bypassing those problems. So if you have extremely wet, waterlogged ground like on this rice paddy, it's much simpler for a couple of oxen to pull your machinery than it is to spend the amount of money needed to buy a tractor that could cope with these very wet, soggy, muddy conditions. And if your farm is on a topography as steep as this, there's no way modern farming machinery can cope with land this steep. The only way to farm land this steep is to use traditional intensive agriculture, to use animal, and in this case mostly human muscle power, in order to terrace, plant, and harvest your crop. Traditional agriculture also has the benefit that most traditional agricultural farms are planted as polycultures. Now, poly means many, so a polyculture is a farm that is growing many types of crop, or crops and animals, at the same time. Polycultures lead to big benefits within the farm. So polycultures can provide many advantages to the farmer. Most crops use nutrients at just one level of the soil. So some crops will take their nutrients from high up on the soil, and some crops will suck their nutrients from lower down within the soil. By planting a polyculture, a farmer can maximize the soil's ability to provide nutrients for his farming needs. By intercropping, utilizing multiple crops in that small area, he can remove nutrients at the top levels of the soil and the bottom levels of the soil and the middle levels of the soil. So he's utilizing all of the soils available to him rather than limiting it to just one level with one single crop. Plants also have the ability to actually release nutrients into the soil. Legumes, such as beans and peas, tend to release nitrogen into the soil. So a farmer could grow a polyculture of a bean crop with a brassica crop like cabbages, and know that the bean crop would be releasing nitrogen into the soil, so the brassicas could remove that nitrogen to produce their nice dark green leaves. So polycultures allow extremely efficient nutrient flow within the soil to maximize the output of the farm. Polycultures also help in pest prevention. If you have a field of many acres with nothing but one single type of crop, pests find it easy to spread from one plant to the next plant, taking over the entire field. With a polyculture, small areas of one crop are interspersed with areas of a separate crop. This separate crop will often prevent the spread of a pest from one section of the farm to another section of the farm, limiting the damage done if a pest actually manages to invade the farm. So polycultures can limit the damage done by pests. The second type of agriculture is industrialized agriculture. Remember, the first type was traditional agriculture, so now we're going to talk about our industrialized agriculture. Industrialized agriculture is mechanized agriculture and is found in most more developed countries. Instead of using muscle power, we're now using fossil fuels, gasoline and diesel. So on an industrialized farm, fossil fuels provide the power to run the farm. So on an industrialized farm, machinery is used to its maximum ability to improve the amount of crop produced per unit land. And there's no doubting that industrialized farms generate much more food per area of land than traditional agriculture produces. One way that we allow our machines to work more efficiently is industrial farms plant monocultures. And monocultures are just large areas of one single crop. So here we have a photo of a monoculture. It's a large field, all of the exact same type of crop. But it's actually more of a monoculture than that. For our combine harvester to work the most efficiently, the crop has to be the same size and has to be about the same shape. So this field is not just the same species of plant, it's also genetically the same plant. These are all clones. So this is a genetically identical crop, each one growing about the same height, each one producing its seeds in about the same place, so that the machine can be built to be the most efficient at harvesting and collecting this crop. Now, polycultures obviously have some downsides. One downside being that this is the exact same genetically identical individual grown over and over and over again in the field. So if one of these plants catches a disease, that disease has the ability to infect every single other plant here. So diseases tend to spread rapidly through modern industrial farms. Not only will they spread rapidly because they are genetically identical plants, but also there are no disease breaks. Because this isn't a polyculture with different types of plant breaking up the planting pattern, there's no break for the spread of that disease. So weed seeds are not prevented from drifting over and landing further into the field. Fungal spores are not prevented from drifting and landing onto other members of this crop. It's one giant open area perfectly designed for the invasion of pests, weeds, and fungal diseases. Industrial agriculture has definitely helped mankind feed the growing human population. The use of tractors, harvesters, and planters, the use of fossil fuels to generate inorganic fertilizers, and the use of fossil fuels to produce pesticides has definitely increased the yield from our cropland. So when we look at our modern history, we see an ever-increasing yield per acre of land of farm used to produce food. So this modern technology, often called the Green Revolution, has led to a bumper crop year after year. So our ability to provide food for our population is really unmatched. We can generate large amounts of food from exactly the same amount of land. Now we need to do this because you need to remember that the human population is increasing on the planet. So our increases in productivity per acre of land have really only kept pace with the growing population and prevented mass worldwide starvation. Previously, without this increase in food production, our population growth would have led to us becoming over carrying capacity, having the limiting factor of food take effect, and caused a dieback of the human population. Today, with our modern technology, we're able to provide more food. Therefore, food is not a limiting factor for large portions of the human population, and the population has grown exponentially. Now, if you look at portions of Africa, particularly if you watch the news, you'll see that famine is often a problem in sub-Saharan Africa. So right now we have the issue of starvation and famine within Somalia due to drought conditions that are there. So it is not every single nation in the world that has no problem with lack of food resources. But as a global society, the global market actually does produce enough food to feed all 7 billion people on the planet. So the problem then is not one of can we make enough food, the problem is one of the food not being distributed evenly to all areas of our population. Some areas produce more food than is needed, like the United States, and some areas can't produce as much food as is needed, such as Somalia. So mechanized agriculture or industrialized agriculture has had some huge benefits in just providing enough food to keep the human population alive. But if you remember that environmental science has this rule that you can never do just one thing, if there's benefits to industrialized agriculture, there must also be some downsides. So what are the downsides to industrialized agriculture? The first one we're going to talk about is the fact that it tends to leave large tracts of land bare and therefore increases the erosion of our topsoil. Now, you should have read the chapter over soil in your textbook and already be familiar with the fact that soil erosion is a major problem on all farms. I'm going to highlight this problem by looking at one event in the 1930s from the United States, and that would be our Dust Bowl. The Dust Bowl was a tragedy caused by human actions. From the water lecture, you should remember that over-cultivating the soil leads to drying of that area. So if you plough your soil and cultivate it at too higher levels, then the soil will dry up. And by drying up, it's then more impermeable to any rainfall that does land, infiltration amounts decrease, and with decreased infiltration, the soil then dries out further, and then you're in that never-ending spiral of dry soil leads to drier soil, which leads to drier soil. So through over-cultivation, our farmers dried out their topsoil. This occurred at a time of natural drought. So a natural drought mixed with over-cultivation caused a drying of the topsoil in the central states area. So Kansas, Oklahoma had extremely dry soils. This combined with high wind conditions meant that large amounts of topsoil were blown away, as you can see in this picture. So these dusty conditions led to the Dust Bowl, topsoil being blown away, destroying the actual farming areas of Kansas, Oklahoma, parts of Texas, New Mexico, and Colorado. Now, these are some of the breadbasket states of the United States of America. These are incredibly important farming states. Loss of topsoil would have dramatic effect on the ability of these farms to produce crops. With a break in the drought and intensive government efforts to improve soil conditions and farming techniques, the United States managed to overcome the Dust Bowl. And we learned many, many lessons in how to protect our delicate topsoil and therefore keep our farms sustainable for many years to come. Two of the most important ways that we have of protecting our topsoil are contour tilling and overcropping. So we're going to start with contour farming or contour tilling. In contour farming, rather than farming and tilling the field to the shape of the field, so if it's a rectangle, tilling your field in the shape of a rectangle, doing nice long straight lines, what the farmer does is he plows his soil along the contour of the land. So that means that the grooves in the soil are at 90 degrees to the flow of water over the soil. So in this picture here, you can see the land slopes down from the top left-hand corner, top left at the top of the hill there, slopes down towards the bottom right-hand corner. The ploughed lines on the field run across the shape of the hill. This means that water travelling down from the top of the hill has to flow into one gully after the next gully after the next gully. So the actual ploughed lines on the field trap the water in place. Now, by holding the water in place, this gives the water time to infiltrate the soil, to soak into the ground and become part of the groundwater. If the farmer had ploughed his field in line with the slope, so with the direction that the water had been flowing down, the lines on his field would have acted like gutters and carried the water away. This would have decreased the amount of infiltration. As decreased infiltration occurred, the flowing water would also have picked up topsoil particles and carried that topsoil off as part of the runoff into local rivers, streams, and creeks. So contour farming ends up having two benefits. Benefit one, it increases infiltration, so it actually causes the soil to soak up more water. By soaking up more water, that actually guards against the soil becoming dry and dusty and actually being likely to be carried away or blown away. So it prevents soil loss by making the soil more moist. Of course, it also helps the crop grow because all plants need water to grow. And the second way that it decreases the loss of soil is, rather than allowing rapid runoff of the water with high velocity carrying particles away with it, it slows down the actual flow of the runoff. By having it have to go over ridge after ridge, the water flow is much slower and therefore can carry much fewer soil particles with it. So contour farming is an extremely important way of preserving the topsoil on our mechanized farms. The second way we can help hold our soil in place is a technique called overcropping. Overcropping basically says, don't leave the soil bare. Wind and rain wash soil away when bare soil is exposed to the wind and rain. So if you can keep a crop, a plant, on that soil all of the time, the chance of you losing topsoil is extremely small. A really good plant to keep would be clover. Clover is a legume, and as a legume, it releases nitrogen into the soil. So you can plant clover on your field and keep it there all year round. It's not a weed, because a weed is a plant that is unwanted and means as we want the clover there, it cannot be called a weed. That clover will help fertilize the soil and will hold the soil in place, preventing it from being lost. The clover will also shade the soil, and by shading the soil, it will decrease the evaporation from the soil, so maintaining soil moisture. All things useful for the farmer. And instead of plowing the field over, you just plant your regular crop right the way through the clover. So you could plant your beans right into the clover, or plant your corn right into the clover. And your crop will then grow up, will grow higher than the clover, will shade it, and then you'll be able to harvest your crop just like normal. So overcropping is a technique useful for improving soil quality and reducing soil erosion. The second problem with industrialized agriculture also comes from the use of monocultures. Because we have large monoculture fields, those plants all strip nutrients at exactly the same level and use up exactly the same nutrients. This leads to the farmer having to apply fertilizers to his fields to make them profitable. So we have to use fertilizers to utilize mechanized or industrialized agriculture. Now, the use of fertilizers has dramatically increased the amount of crop that we get per acre of land. And it's estimated that about 25% of the world's crop is actually directly attributed to the use of chemical fertilizer. So that is, if we stopped using chemical fertilizers, about 25% of our food would just disappear. So chemical fertilizers are vital for modern agriculture. We have to use them to replace the nutrients that the crops are taking out of the soil. In a natural ecosystem, recycling takes place as those plants decay. So in a natural ecosystem, the plant would remove nutrients from the soil, but then die and decay, and those nutrients would be replaced into that soil. On a farm, that doesn't happen. On a farm, the plant grows, we then harvest that plant and take it away from the farm. So we take away those nutrients. So to replace the nutrients that have gone with the crop, we need to use our chemical fertilizer. So what are the actual nutrients that are in fertilizer? Well, the first group are called macronutrients. Macro means large, because these are needed in large amounts. If you look at a bag of fertilizer, it's going to have three numbers on it. In this case, 18, 24, and 6. And these are called the NPK numbers. NPK. N stands for nitrogen, P stands for phosphorus, and K stands for potassium. So this is the percentage nitrogen, phosphorus, and potassium found in this fertilizer. So in the example on the slide, it's 18% nitrogen, 24% phosphorus, 6% potassium. So these are the macronutrients. Nitrogen is definitely needed for a dark green color to your grass. So nitrogen works on the leaves and aids in the production of photosynthetic chemicals. Phosphorus works mostly in the roots and helps develop large root growth. And potassium also works up in the leaves to help allow the most efficient photosynthesis. Now if you add up those numbers, the NPK numbers only add up to 48%. So what else is in this fertilizer? If it's a high quality fertilizer, it will probably also contain some micronutrients. Micronutrients, micro meaning small, are chemicals that are used in only small amounts. So iron, calcium, zinc and boron. So very small amounts of these nutrients are needed to maintain the health of the crop. The rest of it will be filler. And fillers are just inert particles used to allow the spreading of the fertilizer efficiently on the ground. The filler may also allow the fertilizer to be released slowly into the soil. In this way, large amounts of fertilizer are not dumped into the plant, causing chemical burn-in or problems with water absorption. Instead, the fertilizer will be released slowly into the soil, being released at a rate the plants can use it. So chemical fertilizers replace needed nutrients within the soil. However, they don't replace organic matter. The organic matter is what gives soil its dark black-brown color. And that organic matter actually is vital to the health of the soil. The organic matter is what holds the nutrients in place before the plant can use them. They prevent it leaching out. They prevent rainwater just washing all that fertilizer off and into our rivers and creeks. Organic matter also acts as a sponge in the soil, holding on to water so that the soil has a high water content to provide the plants, as well as a high nutrient content. So organic matter is vital in soils if they're going to be high quality. Chemical fertilizers do not replace the organic matter. So if you have a decrease in organic matter in the soil, large numbers of the chemical fertilizer you add will just be washed away. Remember that the world's population is increasing, and most of that population growth is happening in less developed countries. So as the population increases, the use of fertilizer on the planet also increases. So we're using large amounts of fertilizer all around the planet. But in our developing countries, our less developed countries that are showing the most economic growth, we're seeing huge increases in the amount of fertilizers that they're using. So less developed nations, as they start to develop, are rapidly increasing the amount of fertilizer they use. This leads to downsides of fertilizer use. And our first downside is fertilizers are made from fossil fuels. So most of them are made from oil products. So as we use more fertilizer, we utilize more oil. This means that fertilizer price is linked to the price of a barrel of oil. So therefore the price of food gets linked to the price of oil. And we'll talk about more when we look at how mechanized agriculture, industrial agriculture, is really dependent on fossil fuels. The second big downside with fertilizer use is that it doesn't tend to stay on the field where you put it. Because modern fertilizers don't add organic matter to the soil, when we do industrial agriculture, organic levels decrease. And this means that fertilizers can just flow off of the soil as leachate. So as it rains, the fertilizer is washed out of the soil. This leads the farmer to need to add more fertilizer, and the next time it rains, that also washes off the soil. Now this flow of fertilizer off of the soil carries those nutrients into our waterways. So on our graph here, we've got the flow of fertilizer flowing down the Mississippi River and out into the Gulf of Mexico. So all of these areas colored on the map are areas that are actually transporting their nitrogen into the watershed. That nitrogen is being carried through these river systems down towards the Gulf of Mexico. Now you should remember from your water lecture that if you add plant foods to a water body, that causes the growth of algae, and that's called eutrophication. So all of this chemical fertilizer is causing eutrophication of our waterways. When you get eutrophic algal blooms, that leads to a decrease in the oxygen in the area, and we get dead zones. So in the Gulf of Mexico, we now have a permanent dead zone, a section where the ocean just doesn't contain enough oxygen to support life. Now that dead zone actually moves around just in that northern part of the Gulf of Mexico, and you can go on the web and do a search for the Gulf of Mexico dead zone, and you can actually get a daily update as to where it is. This is pushing down the ability of the area to produce seafood. This used to be a very large oyster producing area, and the dead zone will definitely kill oysters. And not only does it kill shellfish, it also causes the death of finfish. So it's having an impact on the fishing community down there. So our farming community is actually having an impact on our fishing community. If we weren't using chemical fertilizers, if we were using more organic style fertilizer, that organic matter tends to trap the nutrients within the soil at a much higher rate, and therefore would decrease the flow into our watershed and the flow into our ocean. So this is a problem caused by inorganic fertilizer use, exacerbated by the growth in population and the need to produce higher and higher amounts of food each year. So the problems with industrial agriculture we've done so far are first off soil erosion. And soil erosion was caused by the fact that industrial agriculture utilizes a monoculture. And monocultures need large crops of land, and as you take a large amount of land, you want to use machinery to plow that, so it's left bare, ripe for erosion. The second problem was soil nutrients are getting depleted, so we have to use inorganic fertilizers, and that links the price of fossil fuels to the price of food, and also leads to the runoff, the leaching of those fertilizers into our waterways, causing eutrophication and a decrease in oxygen. The third problem we're going to do is going to be fossil fuel use. So industrial agriculture doesn't use muscle power as its energy source, it utilizes fossil fuels, gasoline and diesel. This has had major benefits in terms of human work hours. It used to be that many people worked grueling hours, back-breaking labor to produce the food for the nation. And now we can do that same amount of work in much less time, utilizing large combine harvesters and tractors. But all of that energy is put into the cost of producing the food. Therefore, the cost of the food reflects the cost of the diesel and gasoline utilized. So as energy prices change, they have an impact on the cost of food. Not only is it the fuel costs, it's also the fertilizer costs. Remember that fertilizers are made from oil, and it takes about 5.5 tons of fuel to generate about 1 and a bit tons of fertilizer. So as the price of oil goes up and down, that has a dramatic impact on the cost of the fertilizer. The bottom line is when oil gets more expensive, food gets more expensive. Now remember that fertilizer use is dramatically increasing in less developed countries. It's in those developing nations where fossil fuel use in their farming industry is really increasing. It's their population that's taking off. So as their population grows, they have to produce more food. As they have to produce more food, they need to use more fertilizer. As they have to produce more food, they need to use more farm equipment. So the use of fossil fuels is rapidly going up. As the demand for fossil fuels goes up, that's going to be reflected in its price, and its price will go up. Now that means that even though the farms are producing more food, the cost of that food will also go up. So we get into this nasty little sequence of events where as more farms come online and utilize more energy, the actual cost of the food that they're producing goes up. So worldwide at the moment, we are actually seeing protests in many countries on the cost of food. Why is food skyrocketing? Why is there not enough food for my family? Why is food so expensive? On multiple different continents, we're seeing actually demonstrations about the cost of food. You must also remember that fossil fuels are a non-renewable resource. So we're linking our food production to the use of a non-renewable resource. So basically we're making food production non-renewable. That is not sustainable. If your food production relies on a non-renewable fuel source, then what's going to happen when that fuel source becomes depleted and you can no longer use it to make fertilizer or use it to run your tractors? The last problem with industrial agriculture is also caused by the monoculture nature of this industry. Because the monoculture is not just a field of the same species, but that individuals in the field tend to be genetic copies of one another, leads to the use of pesticides. Because all of the individuals in the field are genetically identical, it means that diseases and pests spread rapidly on modern fields. So to control those pests and diseases, farmers look to chemicals. And these chemicals, these pesticides, have now become indispensable to the modern farm. A pesticide is any chemical used to kill or control a population of an unwanted organism. So pesticides are chemicals that try and kill some type of organism or prevent that organism from breeding. The organism they work on is called the target organism. Pesticides come in different types. Insecticides control insect populations. Fungicides control fungal pests. Rodenticides, the rodents, the mice and rats. Herbicides control herbs, the plants. And most of them can just be roughly grouped together in a group called biocides. And biocides are chemicals that kill a variety of living organisms. So if you took an insecticide that also killed rodents and cats and dogs and birds, then that insecticide would more correctly be called a biocide, because it kills many different organisms. So the organism that it's supposed to kill is called the target organism. Any organisms that it wasn't supposed to kill but it has an effect on are called non-target organisms. In our second lecture on agriculture, we'll focus on the use of pesticides and ways to control pests without relying on chemical means.